Derivatives and tangent line problems. Differentiation is just the process of finding the derivative of a function. The root word of derivative is derive. You're deriving this function from your original function. Differentiable means a function has a derivative at a particular point. Back in the 17th century, there were some problems that were worked on, which we'll be addressing in calculus. One of them is the tangent line problem. One of them was how is velocity and acceleration related. One of them is finding the maximum and minimum of a problem. One of them is finding the area underneath a curve. When we're dealing with the tangent line problem, you're looking at the distance between 2 points. You're finding the slope between 2 points, and the slope between any 2 points is given to you by looking at your 2 points and doing the change in the y, which would be this y minus this y, and that's what we have here on top, over this x minus this x, and that's what we have on the bottom. Well, the bottom simplifies down. The c's drop out because the c minus c is 0. That's how you find the slope between any 2 points. Well, your tangent slope for your tangent line really is the slope as these 2 points get closer and closer together. And delta x is the distance between the 2 points. So if they get closer and closer, we're looking at your slope as delta x approaches 0. And so the slope of your tangent line is given to you by the same as what we have up here in the blue box, but just with the limit as delta x approaches 0. So let's go ahead and find the equation of our tangent line at the point -1, comma, -1. The y-coordinate's -1 because if you take your x-coordinate of -1 and plug it in here, you get 2 minus 3, which is -1. To find the equation of a line, in addition to having your point, which we have here, you also need to find your slope. So we need to go ahead and find our derivative. This is the form that they're giving in this section in your book. However, if we tie it in with what we've done before, where it's really the same thing, the only thing is instead of having a c, we had an x before, and instead of having a delta x, we had an h before. So I'm going to go ahead and use that since you're more familiar with that. So we're going to go, our limit as h approaches 0, and we're going to go ahead and put it over h. After the subtraction sign here, we're going to subtract our original function. Before the subtraction sign, we need to go ahead and put in, we changed this to an x plus h. We got to take that and plug it in here for x. And so we get this here. Taking your function with an x plus h in it, minus your original function over h, and we're looking at our limit. Eliminate the parentheses on the top, remembering to distribute through the negative sign here at the end. Then it's just a matter of simplifying that fraction. Collecting you like terms. Pulling an h out of the top because we need that h in the bottom to drop out, because we can't actually take our limit when we have an h in the bottom because we have a 0 down there and you can't divide by 0. So we pull the h out of the top, the h in the top then drops with the h in the bottom. Once we are at this step here, we no longer have an h in the bottom, so therefore we could actually go ahead and take our limit by plugging in 0 for h. So you get a negative 6x minus the 3 times 0, or just a negative 6x. That's your derivative. Now, some of you might be tempted to think, well, negative 6 would be my slope because that's the number in front of x. Incorrect. What we have here is a formula. Our negative 6x is our formula that tells us our slope anywhere along a curve. So to actually figure out your slope, you got to take your x coordinate of negative 1, plug it into your formula of negative 6x. So when you plug in a negative 1 into negative 6x, you get a slope of 6. Now, we need to go ahead and find the equation of our line. You were given your slope, negative 1, negative 1. We just went through a fair amount of work to find your slope. Since we have a slope and a point, we're going to use your point slope formula. So we'll go y minus the y coordinate equals our slope that we just figured out times x minus our x coordinate, which when you're subtracting a negative is once again adding, and then typically we want to just leave our final answer where x is on one, or y is on one side all by itself. The slope of your tangent line introduces us to one of two fundamental operations. One of them is taking the derivative, which is your differentiation. The other that we looked at before briefly was integration, and that's finding the area underneath your curve. So here, let's go ahead and take our derivative of this particular function. You may want to pause the video and go ahead and work out your derivative. So you got to take your t plus delta t, plug it in here for t, and that's what we have here at the very beginning. We then have our subtraction sign, and then after that, it's just your original function, which we have here over delta t with your limit in front. Eliminate your parentheses, combine like terms, simplify, and that's all we're doing. Eliminating our parentheses, we have this. We then want to go ahead and combine our like terms. Our 5's drop out, our 4t squareds drop out. We have this left. You notice you have a common factor on top. So we're going to pull that out so it can simplify down even farther yet. Drop out the delta t on top with the delta t in the bottom. Since we no longer have a delta t in the bottom, we can actually go ahead and take our limit as delta t approaches 0. Plug in 0 for delta t. You'll get an 8t plus a 4 times 0, or just an 8t for your derivative. Then we're going ahead and looking at what does your derivative mean, or not what does it mean, but ways to represent it. One way to represent it is f prime of x. It means the derivative of f of x. Another one is dy over dx. Third common one used is d or y prime. Occasionally we will use the notation of d over dx times your, or of your function f of x, or a capital D with a subscript x of y. They all mean your derivative. The three in the front are the ones that will commonly be used.